Okay, hi everyone. I hope this video finds you warm. Okay, so today we are going to start lecture 5, and with lecture 5 we are going to talk about the programming process. This is involving the problem solving, and we are going to see some simple algorithms. Our main topic today is going to be functions. Functions, we are going to start with an overview of functions, starting with math function, then transitioning to C++ functions. Then we are going to see how we can use them, how we can create them. We are going to talk about arguments versus parameters and the reference variables versus regular variables. Eventually, we are going to be able to do everything using functions, and we are going to be able to create them, use them, pass by value, pass by reference, and having default parameters. So before you start up your Visual Studio 2019 and create Sandbox 5. You may need this project when you review the slides and review what you know about C++ for the exam. Okay, so the programming process is starting with the problem solving phase. Now, in the problem solving phase, you're going to start thinking about how to solve the problem using your brain and your paper. Like a piece of paper and your brain, you need a pen to start scratching on that. See how would you do that. Now, in this case, you have to understand the problem. Now, after you understand the problem, you need to design a solution. After you design a solution, you test that solution. Now, if that solution didn't work in this stage, then you're going to review your understanding to the problem. Then you may find it good. You may need to modify it, then to design another solution, then keep testing until you get everything. And by the way, everything is still on piece of paper and pen. Piece of paper and using your brain and a pen. Now, if your test works, then you're going to the implementation phase. Implementation phase is writing your code. You're encoding your solution. Now, we write the code only after we have a good solution and we are convinced that this is going to work. Now, if your code worked in the testing phase or the testing stage of your implementation, if that works, great. But if it didn't work, then you go to modify your implementation. Now, if that didn't work at all, you may find something that would need you to review your understanding of the problem. So if the testing the solution works in the implementation phase, then you're finished and you're good to go. Now, one practice would be if I would give you this list. We have list 10, 3, 5, 9, 2, 13, and I'm going to ask you to sort it. And now I'm going to ask you to sort it in your head. It's like when I teach a 6-year-old child to sort a list, to basically do comparisons and sort. Obviously, you would start doing comparisons. You're going to start the smallest always, so you would need something called smallest. This is a container that you would you would start with 10, right? You would put that 10 in here. Then you'd start comparing whatever in the smallest with the next number. So 10 compared to 3, which one is the smallest? 3 is the smallest. So I would remove this and put 3. Then 5, 3 with 5. 3 is still the smallest. 3 is still the smallest when compared to 9. 2 is going to be smaller than 3, because remember, we are always comparing whatever number we have in this iterations to the smallest. So 3 is going to be removed and 2 is going to be in here. Then 13, 2 with 13, 2 is the smallest. Do I have anything left? No, I don't. So if you don't, you would have your new list and you would say, okay, I have 2. Then you would remove everything, all the scratches in here, but you would cross 2, right? You would cross 2 because you don't want to keep doing 2, 2, 2, and so on. So also empty this smallest. Now put 10 again. 10 compared to 3, 3 wins. 3 is the smallest. 3 compared to 15, to 50, sorry, 5, sorry. Then 5 loses. 3 is the smallest. 9 is greater, so it's not going to replace it. 3 with 13, 3. So we would scratch 3 here, cross 3, and put it in here. Then you would empty that. You keep doing that with 10. Now 10 with 5. 5 is going to replace it. 5, 9, 13. 5 wins. So 5, cross the 5. Empty that again. Do that again with 10. So that is 9 and 10 with 13. Okay. Now, pretty much this is how you solve the problem, right? Now, this is where we have a pen and paper and we solve the problem. Now, you don't know, but you actually created an algorithm. You created an algorithm. If you look at the algorithm, you create a new list that is empty, which is this one, right? Then you found the smallest each iteration and added the smallest to the list. Now you repeated 2 and 3, found the smallest and put it in the list. This is your solution. So this is called algorithm. Algorithm is like a recipe, right? You have some steps you follow. Now, you may have my solution. My solution is when you find the smallest, you add it to the list, cross the smallest. Cross the smallest. So I won't touch it again. Okay, now, you actually had an embedded algorithm in that algorithm. The algorithm was how to find the smallest. Now, to find the smallest, you heard me here saying you have to compare, right? You have something like you start with 10, you compare 10 to the next. So we have comparisons. So finding the smallest is going to be creating a space called smallest, then put the first number into the smallest. Then if the next number is smaller than the smallest, this is the comparison, right? This is the comparison. So copy the number to the smallest and repeat 3 until you get to the end of the list, right? This is another solution. So another algorithm. So you have algorithm inside an algorithm. So let's talk about functions right now. You have seen how algorithms work because we are going to create functions, which is basically algorithms in their essence. So we have the math functions, which is going to be the best illustration of functions in C++. So for example, if you have this function in math, f of x equal 2x, and you have f of 3 equal what? The f of 3 gives you what? So what you would do in math, you would take this 3 and plug it in instead of in the place of x. Then every x you would replace it with the plugged in value, which is 3. Then you find the answer. So f of 3 would be 2 times 3, which is 6, right? Y equal 4 plus f of 4, 4f of plus f of 5. Then this is going to do the same. You plug in the 5, you find the answer. So that is going to be 14, right? That is 14. Okay, now we said that. How we convert something from math to C++. Okay, let's start with this one. We are going to do this. Now I'm writing C++ function. I'll start with the name of the function. The name of the function is if. Here is the name of the function, right? And we have parentheses. Now, you know there is no ambiguity in C++. You cannot just say X. You have to define the type for X. So I'm assuming it's going to be int. So I want that to be int X. Then the equal is going to be replaced by the brackets. Now, this function is returning something. Returning what? Returning 2 times x. So we would use the keyword return, then 2 times x. Right? 2 times x. Now, you know that every statement in C++ ends with semicolon. So don't forget the semicolon. Now, this is pretty much not that complete. So we need to complete this. How? You should return a values, right? But again, no ambiguity in C++. So the returned value must be of a type. So this is returning 2 times int. This is returning int, right? So you would do int in here. So this is going to be your return type. This is the name of that function. These we call parameters. This is the returned value using the return keyword. So if you would look at how we are going to do this, then you would start thinking about math versus programming. Math versus programming. So what we did is, okay, here is the return type, here is the name of the function, here is the parameter, right? Those. Then you would need the equal, this equal. Now this equal is going to be your brackets. Now, you may want to store the value, the returned value in a variable. So you would create a variable and store the returned value in a variable. Then you return the variable, the value from the variable. Or you can shorten that the way I did, like this, without a variable. So here is how it is in C++. So C++ has different data types, and so we have to add those information. No ambiguity. Again, you don't get to create a vague function. Okay, so functions in C++, we have something called the header of the function, and this is like a contract. Why? Because we promised that we would return something of a certain type. And we promised that you can call the function using this name. And we promised that you're going to give it a value or a variable or an input of a certain type, right? So this is the function header. It's like your contract. And when you use the function, you should give it something, and we call arguments. The thing you give is called argument. The thing you receive by is called parameter. You will get something back. We call it the return value. This is the return type, and inside you must return something. You must return something we call the return value. Now, where could the if function, this function, the one we just defined, be used in our program? Now the answer to this is anywhere, everywhere that an int could be called. Now why did we say an int? Because we are returning an int, remember? So where you can call the function, basically is going to depend on your return type of your function. So if my function returns double, then I would say everywhere that a double can be used. A double can be used. If it's returning float, a float can be used, and so on. So the function header promises that when the function is finished, it will give back an int return type, right? This is why we say anywhere that an int can be used. Okay, so examples of using the function. Now we have the function in here, right? You can pretty much use it like math. You can say y equal 4 plus f of 3. Then the compiler is going to call that function, give it the 3, and start executing statements, and eventually plug the return value, whatever you're returning, in here, then say 4 plus the return value. You can also have it in a switch statement. You can have it in if statement. This is why we said everywhere an int could be used based on this return type. Okay, so remember what I've done is not this format. I didn't create this variable. I didn't create this variable. Didn't do this, right? What I've done is immediately I did this part, right? I did return. So I shortened the function. This is the shortened version of that function. Okay, so what are functions? Why use them? It's actually more than what they are, because they kind of represent algorithms, but exactly why use them. So let me give you an example of a math function. Here's a math function, and you have z equal f of 23. So you would plug the 23 in here, and you'd place every x with it 13, right? Then you would find the result of z. Same thing when you have f of 8. F of 8 is going to be to be plugged in. Then you have this x replaced by the 8. This is x replaced by the 8, and so on, right? So basically, why use them? Because they allow us to simplify complex or long section of code. So a number of actions that can be arranged to be together, grouped to be together in a function and thought of as one action, one unit. This is why we call them actually callable units. Callable because you can call them. Units because you can think of them as a unit, a group of instructions. Each of these functions can be written and tested separately. This is the beauty of having instructions grouped together. So you can think of these as units and you can unit test them, right? So they also allow us to write a code once that is used in several places in program. So basically this is enforcing the do not repeat code. This is getting rid of the duplicates. You can group them all and call them one name, call them function if, and whenever you want to, you want the compiler to visit all these, instead of copying and pasting all these instructions, you can just call if, right? You can just call if. So in C++ we have standard libraries, and there are many functions in those libraries we can use. For example, the isDigit function. Now the isDigit function is taking a character. And it takes a character but returns an int. So what does this function do? This specific function tests whether this character is a digit. It's like when you give it 1. 1 is a character, right? It's going to test. Is it a digit? Yes, it is. So it returns an int. So we are going to have some kind of functions, and we are going to see what are those doing. So this is the function prototype. We call this, remember the function header? We said it's a contract. We have something called function prototype. Function prototype tells the compiler and us what the function needs and what it gives back and how to call it. Based on what is the name of the function. So this function prototype tells you that you have to give a character, and you would get back an int. Now this int is not actually the ASCII code of the character or anything. No, it's actually 0 or 1. 0 represents false, and 1 represents the true. Now, why is that? Why not returning Boolean? B-O-O-L. This is the one we have for false and true, right? Because this is a C, an old C function. An old C function. It's not C++. It's actually the parent of C, right? So it's old C library. So there was no bool then. There was only int, double, and so on, but there was no bool. There was no true false. They were representing the Boolean in integers, 0 or non-zero, right? Remember that from the previous lectures? So how to use a function? So you can use the isDigit function by calling the CC-type library. So you would need to include CC-type library to be able to use the isDigit function. So, for example, I'm going to give you a snap of code that would illustrate that to you. So, cout, please enter a number. So that is going to ask you to enter a number. So you store that number in h. You create an h variable and you store that number in h. Now, what you would do is if the character you entered is a digit, then that would say thank you for the number. Otherwise, if that returns 0, which means it's not digit, then this is going to be treated as false and you would go to the else block, right? To the else block. In the else block, then you would see printed, there seems to be misunderstanding, please enter a number. We have multiple functions you can use from CC-type. You have more than one, and they're always beneficial to get to know these. isDigit, the one we talked about, takes a character and returns an int. And this int is going to be the 0 or non-zero, because it's just representing the Boolean, right? isAlpha is doing exactly the same thing, but it tests whether it's A to Z or in uppercase or lowercase. isAspace is going to check whether the character is a white space. Remember, the white space means a new line, a tab, and the space, like the space. isLower is going to check whether it's A to Z in lowercase. isUpper checking if it's A to Z in uppercase. Now we have two functions. Those two functions return ints. They are called toUpper and toLower. Now they take characters, but the thing is, they're transforming or they are converting the lowercase to uppercase or vice versa. If you use toUpper, then the lowercase character you give is going to be returned as a uppercase character. Same thing for the lower, but it's going to do the opposite. If you give it uppercase, it gives you lowercase. Now the thing is, if you have ch equal to upper ch, and I give, for example, a, lowercase a, I would receive it here when I print ch as a. But if you have toUpper a, then you would get 65. Because that int is not Boolean. It's not representing a Boolean. It represents the ASCII code. It represents the ASCII code of the returned value. Now, this is actually just doing plus or minus the 32, right? From 65 to 97. This is what it does. So it returns an int. If you give it 97, it returns this 65. 65 is an actual integer. It does not represent a boolean, right? So you would get 65. So you would need to store that 65 in a variable of type char. So when you print that variable, the compiler do the implicit conversion to display it. Okay, so where you can find more about these things, about these functions, about more of the libraries that we have in C++, which we call the standard libraries, you can find in cppreference.com or c++.com/reference, or you can find in your book. You can use Google to find more about any function you would need. Okay, now the order of single program that you would know is they include statements, then using namespace stds or whatever using statements, right? Then the main function. This is what you know until today. So today we learned two things. We learned how to write functions, and we learned that functions have prototypes. So where to put the prototype of the function and where to put the actual implementation of the function. So the prototype goes between the using statements and the main function. And the function definition goes below the main. Now there is a trick in here. Now you can abandon the function prototype, but if you have your function definition below, the compiler is not going to recognize it. So you get to take the function definition above the main function if you don't like to have function prototype. However, if you want your function definition to be below the main, then you must have a prototype above the main. The prototype again is the function header, but ending with a semicolon. Remember, we are going to see that together today. Now I'm going to show you two examples of two programs using functions. So the first one is going to be a circle area. So in circle area, in the main function, I'm going to ask you to enter a radius. You enter that radius, and I'm going to plug that in a function, and that function name is circle area, and that returns the area in floating point numbers. Now we are going to create the circle area function. Now first we define the function prototype. Function prototype, what do I want in return? I want a double or a float, right? I want my function to have the name circle area. I want my function to take a double radius. Now this is the prototype. Now why do we have a prototype in C++? Why do we have function prototype in C++? There is a joke that says the compiler in C++ is a narcissist, only sees what's above. So if you have anything below, the compiler is not going to look at it unless the compiler gets the instruction from above to say, look below. Look down below. So we have the prototype because, the starting point of your program is going to be the main function. So the program starts from here, right? Prints inner radius, defines my radius, takes the radius from the user, then goes to this one. First, doing the creation of the float area variable, then going to call this function. Now, calling this function, if we don't have this one, then the compiler is going to give you an error, says, I don't see circle area function. But wait a second, I have it in here. But the compiler is going to say, no, I don't see it. So having this, the compiler goes above to look in the standard libraries to look in the standard libraries. Is there anything called circle area? No, I didn't find anything. Okay, then is there anything in this area? Yes, I have circle area. Okay, I have the prototype of this one. Is it a prototype? If it's a prototype, I mean a function header that ends with the semicolon. This is an indication for the compiler to go below to see the definition. The compiler goes below and sees the definition in here. Sees the definition in here down below. Now, in the function definition, we have the function header. As I said, this matches exactly this one. I'm going to give you something a little bit different in the next slides. But for now, you have to match it. For now, just follow what I'm saying and match this one with this one. If you start function with a function definition, take it and put it above. Again, if you don't wish to have this, if you don't wish to have a prototype in your program, that is okay, but you need to take this one and put it above main. But in my class, we are going to follow the standard of having prototype always above the main and the function definition below the main. Okay, go to the function definition. The function definition is taking a radius, a double, and returning a double. Inside, it defines a constant double pi as 3.1415, and then returns the multiplication of pi with radius and radius, because it's pi radius square, right? So this is going to be received in here and then stored in area, because this is going to be replaced by the value. This function call, this is what we call the function call, is going to be replaced by the return value when it returns, right? Okay, so let's get to see what parts do we have in our function. So the first thing is the function header, or what we call also function interface. Anything inside the function is called the function body. So some people say the function body starts with the curly braces and ends with the closing curly bracket, or some people say it's what's inside. Doesn't matter, right? Doesn't matter. It's the function body. Now, the function header or the interface is similar to the function prototype, as I said. But parameters names are required. What does that mean? What does that mean? Why do we say parameters names are required in the function header, but not required in the prototype? It is what it is. You don't need parameters names in the prototype. But for the things that makes your life much easier, always have the names. Doesn't matter. And again, the names in the parameters are always going to make your life easier. So if you would just say, okay, I would just want in here, for example, I would just want double. That will work if you didn't provide the variable name, radius. That will work, because what it needs in the function prototype is to know what type it gets, what type it gives, and what is the function name. This is what it needs. This is what the compiler needs, because it sees that, do I have the right things for the function call? The function call says I get double. So the compiler is going to match it with this one, says a double, yes. Then returning that and put it in here. This is of type double. Yes, there's going to be downgrading from double to float, but it's okay. Storing that in area, and circle area matches circle area, that works. This is what the compiler needs first. So the compiler sees that and goes to the function definition. So this is why we say parameters names are not needed in the prototype, but they are needed. They are needed in the header, and that makes sense. In the body, statements within curly braces and return statement to indicate a value to be given back. So here it is. We call these things, and we can have one parameter or more than one. If you have more than one, separate them by comma. And you have the function name, and you have the return type. You have local variables in here, like this one is local variable, right? This one is local variable. The parameter is considered a local variable. The whole thing in here, including the braces, is called the function body. And here is the return statement that kept the promise of returning a double value. So here it is, the whole thing. This is the function body parameter, or we can have more than one separated by commas, function name, and you can only have one return type. And here is the return statement. Okay, in the function call, when you call the function, we don't call these what inside the parentheses parameters. We call them arguments. So the insertion command in here is going to be posed for this to start working and executes everything until it gets us something back. And when that gets back something, it's going to be inserted into the cout, into the console. This is how it actually works. So this is the full program of circle area, or finding the circles area. Now, let's take a look at this one. What is happening when we have a function call? So a function call, we have a function called square that takes a number and gives back the square of that number. And here is the function below the main, and the function definition. So when we call it, we say a equal square of a. Here we have a equal 5. Then you have given the function an argument of a. And basically, you don't give a itself. What you give is the value from a. And I'm going to actually teach you how to give the a itself, not the value, in this lecture too. But let's start with getting the value only. So you're giving that an a, right? A 5. Then the 5 is going to be used or copied into num. So num right now equal 5. Num is equal to 5. Num is being used in here, so num 5 times 5, we have 25. After we do the right hand side, we store that in the left hand side. When you return num, that returns 25. Right? That returns 25. So again, the value of a is being copied into the parameter. This is how it's being done. This is why we call it passing by value. Passing by value, we are copying the value. This is why it's called passing by value. Now, parameter variable rules. Rule number 1. Parameter variables are created when the function is called and are initialized within the value of the argument. So this function is ready below the main, but it's not being called yet. Until it's called, this variable has no existence. In the memory. Yes, it has in your code, but in the memory, it's not created. It's being created when you call the function. When you have the right call with the right input. So you have 5. 5 is int. So then the compiler creates int num equal this one. It's like me doing here int num equal 5 semicolon when I start the call. To Changes to parameter variable do not affect argument. Why? Why do we do not affect the a in here? Because it's called passing by value. You only pass the value. You don't pass the variable. 3, parameter variable ceases to exist when the function completes. So when you actually return, so when you hit the closing bracket, every variable in here is removed from the memory. So int num is being removed from the memory. New parameter variables are created for every function call. So whenever you call this function and give it a value, int num, a new int num. For example, if we have, this is the memory, and for this function call created num, and this is location 0x112. For example, you finished this one, so this is going to be removed, and the new and being stored in A. So the result 25 is being stored in A. Then you have another function call. This goes to totally another memory cell. Like this is 0x114. Then this is the new num. This is the new num. Totally another cell. Totally different place in memory. So parameter variable names are only known within its function. Only known within its function. So if you have a variable in here, or this one, or anything inside those brackets, you cannot use it outside. You cannot use it in the main. You cannot use it anywhere except this block, this body. Okay, here's a class exercise with the square function below, like this one, the one I just gave you. Write a max function that has 2 int parameters and will return back a larger of the 2. Also write the main, which can be used to test your function. So you don't have to copy this into your Visual Studio. You can take a look at this and see how we created the prototype, how we did a function call, how we did write the function definition, and so on. So let me just I will do that with you on Visual Studio, but for now, pause the video and take few minutes to do it on your own before you get back to the video to see the answer. Okay, assuming you came back to see how we are going to do it, let me just make sure that this is recording. Yes, it is. Okay, first we would, this is an empty CPP file, so I would start from the scratch. I would do iostream. Then I would do using namespace std. Then I would do int main, and I would have return 0, even though I don't have to have it, but I would always like to have it, and system pose. So I set up my my CPP file. Now I can write a function. So the first thing you do is to write the prototype name, where it's between the using namespace and above main. So what is my function doing? Returning the max. Returning the max. And the max is going to be of type int, and I'm going to call it max. It takes 2 integers, so int a, int b. Now I can have the function in here, the whole function like this, and I do the whole function, or just the prototype of that with the semicolon. And if you have the prototype in here, see that this is green, I'm highlighted, because you need to provide the function definition. So I just copy this, put it below main, open brackets, see the underlining in here? It's gone. Why? Because the compiler find it in here. So if a greater than b, return a, otherwise it's going to be obviously b. So you would return b, right? If a greater than b, then the maximum value is a. This is being returned, otherwise it's b. So how would I call it? I would just print it. Cout max of 2 and 6 and end line. So let's run it. We should see that the max is 6, right? Now the max is 6 in here, so everything is good. Now you can also, what I've done is I give it 2 values. You can give it 2 variables, and I just displayed the result of that value. Now you can do this. Int x equal, I stored that in x, and I print out x, right? You can store the result in x, and x preferably to match the int from the return type. Now you can have that in long, and the compiler is not going to complain. You get an int and you store in long. That works. But if you do short, the compiler should give you a warning, because you would lose some data for the downgrading or the downcasting. Now that giving you the 6, and if you would look at the autos in here, or the, let me just see, or list, okay, wait a second. The short, because 6 still can be in short, and there is no loss because 6 fits in short. But if I would do 1, 2, 3, 1, 4, 5, whatever that is, and I would store it in short, let me just see if this is going to be this number or something that does not fit. See? This gives you a garbage value, because this is wrong. You have something bigger than the limits of short. Now if you do double, that returns a double, and you do double in here, any change in the prototype is a change in the function header, and vice versa. So if you do that and you store the result of this double into short or int, and you just have it int. Now the compiler is going to warn you. It says conversion from double to int, possible loss of data. This is the possible loss of data. You're losing things from this number when you sort in int. Even though the number matches, so you haven't lost anything. But what if the result was return a double, and you store the double into int? Then this is losing the precision, right? This is losing the precision. This is why it says possible loss of data. Okay, here is the solution. Okay, moving on. So information to a function can go in from parameters or an input streams. So the function, here is the function. It could take parameters, or it could take input streams data, and it could just output that to the console, or give you a return value to store it in a variable. Now, we said we are going to give you another example. Here's the other example. So the program description says you get two whole numbers from the user, and then add all the numbers from the smaller number to the larger number and give the sum back to the user. So if I give you two numbers, 1 and 5, you would do 1 plus 2 plus 3 plus 4 plus 5, and you give me the output. So everything in between. So the program design should be, first you prompt this number, you prompt the user for this number, then you arrange them. If I give you 5, 1, you would say, no, I should get 1, 5. So you would arrange them, right? You would swap them. And then you would calculate the sum from the smaller to the larger value, right? And then the last thing is displaying the sum. Okay, so here's the range.cpp. Here is the compact version of our program. So we are going to write two functions. One is called prompt and read int. This is going to prompt and read the first number. Then we are going to call it again to read the second number. We have sum range. Sum range takes a start and end. And sum range is going to sum everything starting from the start to the end. Start plus the next value until the end. So in the main function, I'm calling the prompt and read int for both num1 and num2 that I'm getting from the user. Now I'm rearranging them. If num1 is greater than number 2, if I give you 5, 1, then what you would say is, no, I should have 1, 5. So I would swap them. Now the swapping is usually happening with the extra variable. It's like when I give you 3 glasses of juice. So let's say we have apple in here, we have orange in here, and this is empty for the swap. Because if I don't have this one, and I ask you to swap those by preserving the 2 glasses, you won't be able to, right? So I need the temporary glass. First, I put the orange in there. Now the orange glass is empty, and you put the A in here since that is empty, right? Now this one is empty, so you can put back the O. And then this is not needed anymore. Now we swap them, right? Now we swap them. This is exactly what you can do in programming. You create a temp and you store num1 in it. Then num1 has no use. You can store num2 in it. Now num2 is the one we want. And num2 has no use. You can put back the temp in it, and this is the swapping. So then you call the sum range function to sum from num1 to num2 and store that back into a variable. You call it range sum, and then display it. The sum from num1 to num2 is this, right? Is this. Now let's go and see the prompt and read int. Now the prompt and read int function is going to ask the user for a number, right? Define a variable called response because you needed to take the response from the user. Take the number. Then you return the response, right? Then you return the response. It's of type int. Okay, everything is good. Sum range is going to take the start and end, and it's going to define a total going with a for loop starting with the start value. Now if that is being 5 and this is 10, that's going I equal 5, then 5 to the total, then 6 to the total because we are doing plus plus, right? 7, 8, 9, and 10. Okay, now after that you would return the total. Now the description says compute the sum of all integers from the start to end. It's not that accurate, right? Because that description could be more accurate if we said, if the start is greater than end, then return 0. Then return 0. Because this function is independent of us doing the exchange in here. So this function doesn't know that it gets things arranged, right? So the description would be better if we have if start greater than end, then returns 0. So, for example, if this is 10 and this is 5. So this is 10. Then we'd say if I less than end, 10 less than 5, then we are not doing anything. So the total return is 0. The total return is 0. So what's wrong with this function? What's wrong with this function, the prompt and read end? It takes a something from the user. Now I said something because we don't trust the user to give it an integer, right? So it could be given a bad data. So we need to improve it. So we would return we would get anything that could be corrupt, and we would tell the user, no, this is corrupt. So we would do cout, enter a whole number, character ch, cin, ch, while is digit ch equal false. This is from CC type library, with the one we used. Now, if is digit, this character you received from the user, is not a digit, then you would ask the user to enter another number. If it's a digit, then you would put it back in the cn. You would put it back in the cn, in the stream. This is the stream, right? If I get 1, I would check, and if that 1 is a digit, yes it is. Now, when I took it, that one, I took it outside, and I put it in ch, right? So ch equal that one, and now the stream is empty. Now ch equal 1. Is ch a digit? If yes, then put it back in the cn. Why? Because I took it as a character. I need to read it as an integer, so I read it as an integer. Now, you don't have to actually put the 1 back again. The compiler is going to check when the compiler executes cn response. It's going to check, is there anything in the data stream that I can take? Yes, we have the 1, then take it. Then take it and return response. Return response. Now, the putback function and this while loop are working together. So they're going to stop, like if you have 1, 2, 3, 4. If you have 1, 2, 3, 4, and here's the data stream. So if you enter the 1, 2, 3, 4, it takes every time, it takes this, put it as ch equal 1, then remove it, then says, okay, I take that, check. Is it integer? Yes, put it back. 2, take it again. 2, then put it back. 3 would take it, remove it from here. Then 3 is a digit, put it back. If, let's say, you did 1, 2, 3, 4, then A, B. Takes a, is it digit? No. So go back and put all the ch, put all the things in the stream, then take it as an integer in response. Now, put back allows a character to be put back in the input stream, because usually you can then reread it as a different type, because we were taking that as a character in here, but eventually we'd need it as an int. So here is the final version of our prompt and read int. Now, prompt and read int is having a hard-coded inner whole number. Now, you can do an extra practice. Is by making this message to be received as a parameter. by making this message to be received from the main as prompt. So prompt, you give it this message in the main function. Now we have something called void functions. Void functions are the functions that does an action, but does not give back any information. So everything we have been doing is returning an int, returning a double, returning something, right? This time we are not returning anything. So if your function is returning nothing, it does something. For example, it prints something to the user, prints something, displays something, or does certain calculations or doing something inside, but does not return anything particular. So you would have it of return type void. Void means nothing or empty, right? So if you have your function of return type void, which again does something inside, whether it's displaying or doing certain calculation or anything, but does not return any value, then you don't have to have return. You can have return on semicolon like this, or not, because the return is optional. And your function return type is void. Now, the scope refers to when a variable name is seen or available for use. So we have two types of scope. We have local scope or we have global scope. Local scope, as I said, within a block. Local variable is a variable that can be seen and used within a block. A global is outside any block whatsoever, any block. So a block is a list of statements inside a curly braces. Remember that when we said the body of a block, the body. This is a block. A list of statements, whether it's one statement or more than one statements, right? More than one. Inside curly braces. Now, blocks can be put anywhere a statement can be put. You can put blocks anywhere, outside main, inside main, anywhere. A block within a block is called nested or embedded block. A variable name is known only in that block it's created in, and any nested blocks inside that block. It's like when you used for loops, you can see the variables from the outside, right? You can see the variables from the outside, above, not below the for loop, because the for loop has a block. This is the block. You can see any variable from outside, and you can see anything from inside but above, where you're at. Now here's example of local variables. We have void foo, and we have the function block. This is the function block. Now we have int I. When you print it, you print int, you print the 1, right? Because you have it of value 1. Now we have a block. Now you can have a block without any like for loop, while loop, or if statements or anything, just a block. Now you can have it because you want those variables to be this block specific. This is why we have blocks usually. Now a block, we have int j equal 10. We print I and j. We print the 1 and j, the 10. So 1 and 10. Now we say I equal 1. I can still see I, right? So I modified it to be 2. Now again, the change is permanent. If you change the variable from anywhere, it's permanent, right? It's permanent. So I equal 2. Now I, j prints 2 and 10. Printing I and j from the outside of that block where we changed it to 2, still the change is permanent. But j is illegal, is not seen, because it's defined inside a block, so it can be seen only here. You cannot see it from the outside. This is why it's illegal. So name reuse. If a nested block defines a variable with the same name as the outer block, the new variable definition is in effect in the nested block, and it blocks the name or hides the name from the outside, the variable from the outside. So the local or the inner variable names hide the view of the outer variable names. Let's have an example. So if I have int I equal 1 and I print that prints 1. Then I printed I until now, I still see I as 1. Then I defined I as different data type, like I equal A. Then when I print I, now I is the A to me, because I'm inside that block, right? And this I blocks the view of the outer I. Now when we are done, this variable is destroyed, so I get to see my I equal 1 again. So I print 1. Printing I from outside is going to be unknown, so this is going to be illegal. Because of these blocks, and you're printing that outside of that block. Okay, here it is with that exactly explains where is each block starts. Where is each block starting? So here is the block, closes this block, here is this block, and the third. Anything inside cannot be seen outside if defined inside in here, cannot be outside. Anything inside of this cannot be seen outside if defined inside, and so on. So the global scope, a variable not defined inside a block, are global variables. So a global variable can be used by any function that is defined after the global variable. So global variables should be avoided unless they are constants. This is why we always have constant global variables, because they cannot be changed from anywhere. But if you have a global variable, if you change it from anywhere, like inside any block or anywhere, that change is permanent. And we hope that we don't change it mistakenly somewhere. So for this class, I'm going to ask you to define only constant global variables, not any global variable. So global variables can even be used in another program files, like you can see them from any files outside, as long as you have access to that class or that file they're defined in. So cout and cin, they're actually global variables that are defined in the IOStream library. This is why we can use them when we include that file. We are not inside the file that cout or cin defined. We are outside, but we still have access to them. So local variables can reuse a global variable's name, thus hiding them, right? But if you use the unary scope operator or the scope resolution operator, the 2 colons, you can access the global variable, and I'm going to show you how. If we have int I equal 1, this is outside any block, so it's a global, right? And we can print it in here. We're still using the global, printing 1. Then we define character I equal 1, and this does not have to be a character. It could be the same type, like int I equal 1, whatever, equal 8, which is storing 97. So this is cout I, this is printing the local, because the compiler sees whatever nearest. Now if we add this colon, even if we have another I in here, this says go to the outside and print that. Uses the global. Then I without 2 colons, without scope resolution operator, prints the local. This prints the global. And again, the change in here is experiment. So you change actually the 1 to 2, right? So this one is using the global because you're outside of the blocks. So this is not seen from down below. Now, if you use something like this, why do we say we hate to have global variables that are not constant? Because if you have big program like this, you have int I equal 1, and this is creating a global variable, and you change it in here, you keep changing, you don't know, after hundreds of lines of code, when you print it, you printed the value of negative 243. Now, you don't expect that. You would expect like different value. But something wrong happened in here, and you change it accidentally without your knowledge, or you don't know that you were actually doing a change to the global variable because you thought that you were doing to local variable, something like that. So where did I change it? I don't know, because you have hundreds of lines of code. It could be somewhere, it could be anywhere, right? So this is why we'd like to think of the global variables are like global bank account. You can change them from anywhere, you can access them from anywhere, so be careful. So let's have some review with the names associated with the functions. What is this called? And what is this? What is this? What's the whole thing called? And what is this? Okay, so for this one, it's called function prototype or function declaration. This one is called function body. The whole thing is the main function. This is the body, and this is the header or the interface. This is the interface or the header for the function test, and this is the body, and the whole thing is called the function definition. So let me just make sure it's recording. Yes, it is. Okay, so what are those things called? Those variables, this variable, those variables, and those, and those. So those are parameters. However, those are arguments. This one is global variable. Those are local variable in here too. And those are parameters. Those are parameters. So if you have a variable in the parentheses of the function declaration or the function header, it's called parameter. If you use the variable in calling the function, it's called argument. If you have function inside a block, it's local variable. Outside any block, global variable. So, as I said, the function parameters, if they are in the prototype, here is what makes this a prototype, the semicolon. If it's in the prototype, it doesn't have to name your variables. You just define the type. So parameters names are not required in the function prototype, but again, it's usually best to have them. In the function header or the interface, they are required. You must have them, because if you don't have them, how would the function body knows what is this if you don't have D or E or the function the parameter name? So enough of review, let's get to the new thing. Okay, now consider if we want to change the previous program example. Instead of doing the change with 3 glasses, remember the 3 glasses, 1 temp variable. So we are going to do the swap function, and the swap is doing the temp and the exchange, the swapping of the two numbers, number 1 and number 2. So what if we want to do that? What if we want to have a function that we pass number 1, number 2, and then we receive number 1 having the smallest, number 2 having the largest? What can we do in this case? So here is the swap function. Pretty much we went to the previous code, we copied this, right? And then we said, okay, we're going to put it in a function. It's called swap, takes in int a, int b as inputs, returns nothing. And if you want that or not, it's up to you. So what we want to display is 5 and 12, 5 and 12, if the input was 12 and 5 to be swapped, right? So what do you think will be displayed? So no changes to A and B, and we have no effect on num1 and num2. So what we have is num1 still 12, num2 still 5. But wait a second, what have we done in here? So what we done is we locally changed the values of A and B. Why is that? Because when we received this, we received only the 12. We did not pass the variable num itself to be changed. We passed the value. So that was passing by value. So what we want is a parameter passing method where changes to the parameters would change the arguments. Changing parameters, any change on the parameters would change the actual arguments. This is what we want, right? So we need a new way. The new way is going to be called passing by reference. Before you know what passing by reference is, you need to know what reference variable is. So a reference variable is creating a second name, alias, for an existing memory location. So a reference variable refers to another variable. It's like I say, okay, I have my bank account and it's used, and I can put money inside, I can take money, and it's mine. And having another variable refers to it, or giving another person access to it. It's like giving my wife access to the bank account. Now, we both, me and my wife, we can put money. So if I would put money, I would put $1,200. Now my wife can have access to that $1,200. She can raise it and add 200, so the new value is 1,400. Or she can take. If she puts 14, and I can take some of it. I can take 50, for example, right? So we both have access to the same location. We can store money. We can retrieve money, right? Okay. So how do I write reference variable? So let's say you have int num equals 0. So in the memory, num is pointing to this location and stores 0. Now to create a reference variable, you need to create another variable, int a, or call it ref_var, and you would put num. But if you do this only, then you're creating a in here and you're putting 0. Now if I change this num to 15 later, so if I do this, if I do num equal 15. This is changing to 15, but this is still 0. So you need something to connect them together, to connect them. The connector in this case is the ampersand. If I do num equal 15, this is immediately 15. Whatever change on this is the change on this. So is it this great that we can actually do what we needed in here? If we make our parameter a reference variable. Now, before saying that, let us talk this through until you see how it's actually being done. So int num equals 0 created num and put 0. Then int ampersand ref var, this is my reference variable now, and it refers to num. So basically ref var is not actually storing value like this one. It's pretty much storing an address. So this says I refer to this. So if you printed this one, it's going to print what it refers to. Then let's say now you change ref var equal 42. If you do ref var 42, then this value of num is being changed to 42. Now if you printed num to make sure that actually num is being changed, num displays the 42. So some rules for reference variables. So reference variables must be given a variable to refer to when it's created. So basically, if I do int ampersand ref var, I cannot say semicolon. No, I have to continue equal and a variable to refer to. And it refers only to variables. So you cannot say equal 15. No, only variables. So int num equals 0, int num2 equal 10. If I'd say int ampersand ref var equal num, then ref var referred to num. Now, reference variables cannot be made to refer to another variable after creation. So if you did this, you cannot then say, okay, ref var now refers to num. No, this is not actually a reference, what you are trying to do in this line. What you're doing is saying, take the value from num2 and store it where ref var refers to, which means take the value from here and put it in here. This is exactly what you're doing. So the special meaning of ampersand when used in a variable declaration, one creates a reference variable. So this is how we create a reference variable. Now ref var is a reference variable that refers to num. Now, how about doing this? Is this actually saying, okay, if you don't have this, then that means you're putting the value in here. But what if I have this ampersand? Does it mean that now this variable refers to this? No. This is an error. It's not going to be recognized by the compiler. So how does this help us? Again, this helps us when we pass information to functions. So how information normally passed to a function? By value, right? This value is being passed as the first parameter. This value is being passed as the second parameter. Now, if the parameter is a reference parameter, then the parameter becomes an alias or a second name for the argument, right? So every change on the parameter is a change on the argument. So the reference parameter is just a local alias for the argument. Function header determines whether a parameter is being passed by value or by reference. If you have this ampersand in your parameter name, in your parameters, then it's passing by reference. If you don't have this, then it's passing by value. Okay, so here is the swap function. The swap function is a function that takes a parameter reference, basically reference parameter, to the argument and another reference parameter to the other argument. Now, just doing this, whatever you do inside on A and B is being done immediately on number 1 and number 2. So basically, this indicates passing by reference. Passing by reference, when called, A and B became aliases for number 1 and number 2. So let's have some things that we are going to try. Now let's say that swap is this swap, which uses passing by reference. So anything I would do on A and B is being done immediately on I and J, right? On I and J. So if I equal 5, J equals 6, and I swap them, after the swap, I is 6 and J is 5. Okay, so if we are doing that on A and B, and I swap B and A, you're again still swapping the values. 7 being in B and A takes the 8, right? However, if you try to do this is not going to work. There is an error. Why? Because the input must be a variable. If you're referring to something, it must be a variable, right? But you're passing values, you cannot refer to values because this is a reference point. It has to refer to a variable, right? So you're not passing variables. This is why this would give you a compilation error. Now, sort function. Practice passing by reference. So write a sort function that has 3 int reference parameters, num1, num2, num3. And inside your sort function, you will put the smallest number in num1, the next smallest number in num2, and the largest would be in num3. Now, you have swap function. You have a swap function in the algorithm library. It's called algorithm. You could have included algorithm, or you can write your own swap function. You can find it in here actually, right? So if this is going to be your main, and your main is defining 3 variables, you take 3 inputs for 3 variables from the user, and you put them in sort. So as you can see, sort is a void function, right? Because it does not return anything. It does not store anything. So it's internally changing num1, num2, num3 values and arranging them from the smallest to the largest. So pause the video, think about this, and come back to see the answer. Okay, assuming you came back to see the answer, here is the answer. I have the swap. And here is the function definition. Then I have the sort function declaration. Here is the sort prototype. It takes 3 variables, A, B, and C. And those 3 parameters are reference parameters. Here is the main. I just copied the main and pasted it in here. Now in the sort, it does sort the 3 parameters. And any swap, anything is being done on A and B is done on num1 and num2. Anything done on B and C is done on num2, num3. Anything on A and B again is num1, num2. So let me just explain to you how this is working. So let's say we have 6, 5, 3. Here are my 3 numbers, 6, 5, 3. Now, in the first round, or not the first round, it's in the first if statement, I'm saying if A greater than B, swap them. Is A greater than B? Yes. So swap them. 5, 6, 3. 3 goes the way it is. In the second if statement, I'll say if B greater than C, is B greater than C? Is B greater than C? Yes. Swap them. So this goes the way it is. And 3 and 6. Now, is this sorted? Not yet. So the last if statement says if A greater than B, is A greater than B? Yes. Swap them. 3, 5, 6. Now we have a sorted list. Or basically 3 number. Okay, now we have something called constant parameter. Constant parameter, the const modifier can be used with a parameter declaration. Now, const indicates that the function may not modify the parameter. You know, const, we use it if we are creating a constant variable. Now, if you want a constant parameter, that means this function may not modify this variable. But wait a second. Why do we have a reference to it? Basically, we create a reference to a variable or a reference parameter if we want the function to modify it. But why do we actually create a reference variable and we have it as a const? A const means this function cannot modify it. So basically, we are contradicting ourselves, right? By saying the function may modify, then function may not modify. Actually, we are not. Why? Because we use constant parameters if we actually want the function not to modify the parameter, but also because this is not passing by value. Passing by value, you know, it involves copying and pasting, right? Copying the value itself. So if you are concerned about the time taken by copying the value or the space by the new value, then you may just have a reference parameter to the old value, to the past value. And this will save you some copying time, and this will save you some extra space. For example, if I have a string of 50 gigabyte, do I want to actually copy pass by value, meaning copy the 50 gigabyte to another variable with the time spent in copying and pasting and the new space for the extra 50 gigabyte, or just this that stores the address, right? It's not storing another 50 gigabyte. It stores the address. This is the benefit. So the benefit is this. For large variable, making copy of the variable can take time, and so it's slower. Also, may take extra space. Okay, review. If we call this function, how the argument is being passed in. It's being passed by value because it has no ampersand. What about this one? There is ampersand, then passing by reference. What about this one? Passing by reference, and it's also constant, so it's being passed by a constant reference. Something we call a constant reference, which makes it a read-only value or a read-only variable. Okay, we have something called default parameters. Default parameters, this functionality or this features allows the programmer to create a function where the parameter has a default value that can be used or replaced. For example, if we have void print line of stars, we are going to print lines of stars. And we are saying, okay, for the default, print only one line. So where's the default? We call them default parameters. So the default is the parameter. You have it in the function prototype and the function header. So if I did not pass anything, even though it must take something, right? It's okay. Why? It's okay to pass nothing. Because if you pass nothing, it's going to use a default value. Usually, if we don't have this, you must pass something because it's going to be used inside. But if we have a value actually, so you don't have to override this value, right? So if we pass nothing, this is going to print one line. If we passed something, it's going to change the value to the new passed value. Passed value. So it replaces the default value. So for example, if I'm printing a character, I'm printing the character, for example, I'm printing the tilde, and I'm printing that 18 times. So the function below the main is going to be for starting with I0 to I less than 80. So print 80 times this character, right? So if I passed nothing, it's going to print 80 tildes. If I just passed the hyphen, it's going to print 80. It's going to use the default for this one and replaces this with the hyphen. So printing 80 hyphens. For this one, printing 20 stars. 20 stars. So if we had the following function prototype, def partist num1, num2, and num3. So once you use default parameter, the rest of the parameters must use their default values. So for example, if I pass this one, 11, then I have num1 being 11, because this is overridden, and this one, num2, stay the same, 2, num3 stays the same, 3. So no problem, all is well. But if I have def partist like this, I would think that I'm changing only num2, but num1 stays the same, num3 stays the same, num2 being 22. No, actually I'm not doing that, because this is going to give you a compiler error. So a good example is always have your default parameters at the very end if you have a mix of non-default and default. Non-default and default. Always have default parameters at the very end. Why? You will know why when we try it in this example. So if we have this non-default and default parameters. So if we do this, this is going to work out with no problems, because this is going to say 12, then 34 and 100. 12, 34, 100. That works. So that works. If we are going to do 74, this is 7400. That works. Now if we pass nothing, that won't work, because this must receive a value. Must receive that. This may receive value, this may receive, but this is a must. So this is not going to work. If we pass 1, 2, 3, then it's going to be 1 for num1, 2 for num2, 3 for num. Now if we go back to this one, if we have this default and those non-default, so you know that you cannot do something like this, right? So how would I say in this example, how would I say pass this value, pass a value for this one, but don't do for this one? So comma 1 and 2, this is not going to work, right? Okay, going to this one, print banner activity. So using the default parameters, create a function that uses default parameters that will print a banner on the screen. So using the default values, you print something like this. Remember, programming is fun. 2 exclamation points at the very middle, and the middle in here, and the middle in here. Now, to be honest, I did this positioning of this message using spaces or tabs. And those are going to be using for loops. So let's see the code for this one. So the print banner function prototype is going to take a message. So the message is a must. And if you did not pass anything for character, it's going to print tildes. How many lines for the header and the footer? 3 lines for header, 3 lines for footer. And the width of each line would be 60 characters. 60 characters. Now this is the prototype. Now here's a possible main function. Here is my message. Here's my message. And as I said, the positioning was using tabs, white spaces. And you called print banner with the message. If you don't want the tildes and you want customized character, header, footers, and a number of characters printed in one line, you can do that in here. The message, question marks, and 2 headers, 2 footers, or 2 lines for the header, 2 lines for the footer, and 40 for the width. Now, here is possible function definition. I'm giving you the function definition. So it's just going to print the footer, the header. Once printing the header, you print the message and you print the footer. Now, this is easy. Just double for loops, one for the number of lines. Then this is printing the characters in line, adding a new line, the second line in the header, and so on. Then the message and this one. So now what I want you to do is if you want to gain extra credit, take this code. Here's the code. Everything is with you, right? Take this code and position the message using a formula of your creation. What do I mean by that is, see, remember, programming is fun. I don't want you to have any tabs or anything, just the message. And the way this message goes into the center, exactly the space in here equal to the space in here. How is that being done? It's up to you. It's using a formula. A hint to your formula is using the message length with the width of this line. So if I would print, for example, my name, Ehab, this space is equal to this space. Using the formula, using the length of this one and the width of this line. This width is this one. Now I give you a hint. I almost gave you the solution. Now once you're done with this, go to the modules. Let me go to your modules. Here it is in lecture 5. You're going to upload your file to the print banner. You can upload it to this exercise. Okay. So, done with this one. Let's talk about function overloading. Now, sometimes we want to use the same function name to do similar actions on different data. Like what? If I would like to find the maximum of 2 numbers. Now, the numbers could be integer and a float, or a float and an integer, or float and a float, or 2 integers, or any of these permutations. Right? So, for example, the minimum or the smallest thing of integer, double, string, you want the maximum or the largest thing of those or any of their permutations. So int min, int num1, int num2. Double min, actually using the same name. This is what function overloading means. Having the same function name for 2 or more functions. Now, function name can be overloaded if two functions having the same different parameter list, not the same parameter list. Now, when we say different parameter list, I mean different number of parameters like min and min, both having different parameter lists. This takes 3 parameters, this takes 2, and so on. Or different types, this takes integers and this takes double, even though the number of the parameters are the same, but they have different parameter values, even just one, even if this one 20, which means int and a float. Just one change is good. One change is good. Now, or if you have different in number and the types, both. So you can have function overloading on 3 things. The number of parameters are different, the types of the parameters are different, or the mix of those. Mix different number and types. Now, that said, you cannot use a function overloading if the only change is the return type. So if we have min takes int and int, min takes in an int, and the only difference is this is not valid function overloading. This is not valid function overloading. Now, here is a function min that returns the minimum of 2 numbers. This is printing if you're using the min, printing using the min function and returns the value. Using the min function of double, this is using the int, this is using the double, and returns the value, right? Returns the value. Now, if we have those two, and I have int a, b, and I have a with 10, b 20. I have x and y of type double, and they are 4.4 and 9.2. Now, if you used min a and b, this is pretty much straightforward. A is int, b is int. It uses this one. If you used x and y, this is pretty much also straightforward. It uses this one, right? It uses this one. So if we used this, we have a of type int, and this is to be thought by the compiler, since it's just a value, the compiler is going to match it with the default for such thing. It's a floating point number, and the floating point number's default type is the double. So the compiler is going to look for int and double. Do we have int and double? Do we have int and double in here? No, we don't. So what the compiler is doing, the compiler will try to find the best fit. First, the compiler looks for the definition where exactly we have a match. If there is no exact match, the compiler will attempt to change the arguments so the function can be called. So this is a dangerous feature because you may confuse the compiler, and you don't want that. So, for example, in this case, after I tell you what is going to happen in this case, you will know what is the answer to this question. So we have function A, function B, and function C. So if we have 2 and 1, int and int, this is going to call this one, right? It's going to call this one. If we have 2 and 3.2, it's going to call this one? Or does it? If we have 2.5, is it going to call this one? Or not? So this is actually going to cause you a compilation error. Because what is this type? It's a float. What is this type? It's the default. The compiler is going to match it with the default. The default is double. Is double a float? No, it's not. It's not. And the compiler is going to see that as downcasting. You are downcasting from double to float, so you're losing information. This is how the compiler sees it. So the compiler is going to give you a compilation error. So how do I fix that? By saying 3.2f. 3.2f will make the compiler sees it as a float, and now there is no confusion. So the compiler calls this one. Now, for this example, the one I just said, there is going to be clear up if we see this example. So this example is going to clear things up. So if we have int and double exactly like this, right? Exactly like this. And we are passing 2.5 and 1.5. Now the 2.5 is immediately calling the double and the double because it's obvious, right? The compiler is now going to be confused. But for this one, so if we have 2 and 3.5, is your recommendation for the compiler to downcast and call function A, or upcast and call function B? Now usually if it's up to me, I would upcast this, right? And make it 2.0 and call the function B. But actually this is going to cause a confusion to the compiler, because the compiler is not a human. Compiler looks for things that is either it's obvious or it's easy to figure out which one to go with. Now, if we commented this one and we only have one function with two doubles, if you pass this, it's immediate call, right? It's obvious call. Two doubles gets two doubles, that's great. Now, if you called this one, then the compiler goes, okay, I have double and double, and I have int and double. Since I don't have anything else to confuse me, I can upcast this one. I call this with no confusion. Same thing in here. Upcast this one and no confusion. So max function overloading. So write 3 overloaded max functions and then test them. For example, if you try this one with 2 integers, this one with 2 doubles, and these with 2 strings. And the 2 strings are going to compare the characters. So cat and apple, this is going to say this one is the max because it has more characters. So try this. The string that it has the longest length, you can call string, and you can use str1.size or .length. Okay, now enough with functions. This is pretty much concluding the whole lecture 5, and you go do everything in lectures 5 modules, and have a good day. See you in next lecture.